piece by piece. The scenario is not something that should kind of blow us away because we've been kind of talking about the same thing over and over for the last few days. But you may gather, since we've been talking about it for a while, that it's probably kind of important. So the motion of the car starting from position x equals 0 is modeled in the velocity versus time graph at the right. So first question for you is, does it start from rest? No. How do you know it doesn't start from rest? At time equals 0, velocity is not 0. Yeah? So that means that if it started from rest, it started from rest somewhere else, right? And then just happened when it crossed that 0 line to be going how fast? 12 meters per second, right? All right. So let's take a look here at what they're going to walk us through. We've been gathering that this, like, walking through things means something, so we got to go through this. So we see that it's a line. I remember I mentioned that AP really likes lines, right? And I do too. And you do too, because you know what they are. Y equals mx plus b. We've got that here, okay? Write an equation including units for the velocity versus time line given above. So what corresponds to the y-axis? Velocity. It's true. What goes in here? The number with units. The slope. What did you get for the slope? Oh, yeah. -4. -4 what? Meters per second? Squared. Why squared? It's true. We're looking here, right? Change in y over change in x. So you've got velocity versus velocity, meters per second, divided by seconds, meters per second is meters per second squared. Yeah. All right. Everybody comfortable with that -4? Okay, we had a conversation in the last period, so I just want to make sure that the scale here and the scale here are different. We need to acknowledge that we're not going to just count boxes, because counting boxes does not give you a slope. It just gives, well, I mean, it does, but it's not the right slope necessarily. So you need to make sure that you're paying attention to scale. What's on our x-axis? What goes here? Time. Plus, oh, we've got a y-intercept today, don't we? Yay for y-intercept. 12. 12 what? Meters per second. So this thing right here, this 12 meters per second, sometimes we call this the initial condition. The thing that we want to pay attention to, that is the beginning situation. It says, write a more general equation for the motion of the car using standard physics symbols. So what might fit into this space? I don't know if you recognize that you needed to fill this space with an equation. So we're going to use x, v, t, and a. How would you do that? Did you fill in one there? Or did you not yet fill that in? What would it be? Don't overthink it. Don't overthink it. What's the first part? Vx or v, yep, equals a t plus x. Yeah? Is this x? What does this represent? Initial velocity, right? So that x is not an x. What should that be? Yeah, it's the initial velocity. So Vox is what it looks like in your equation sheet on that equation sheet. I would write this as V final equals AT plus V initial. That's Ms. Carbling's way of doing that, but either way works, okay? This is the first equation that exists on your equation sheet, on your yellow sheet. Yeah, we're building the equation. There it is. The slope of the velocity versus time graph represents the? Indeed it does. I kind of feel like that question should have come first, but that's okay. They didn't ask me when they wrote the paper, did they? Jeez. So one of the things that you will see a lot on questions, and I really, really like this from a pedagogical, do you guys know what that word means? Pedagogical means like teaching approach, pedagogical approach, is to tell you what a student says and see how you feel about it, whether you agree or disagree. This is a way of asking questions that you will see a lot when we're preparing this year and on the AP exam. So we're going to meet Carlos. Carlos makes the following claim. He says the car is slowing down for the entire distance it travels because the slope of the line is always negative and never changes. So the trick is that you have to not only understand the graph yourself, but you also have to be able to take somebody else's thought process and see if you agree, partially agree, or completely disagree. Okay? This is really interesting because it allows for somebody, me or some outside entity, to determine whether you really understand the physics behind things. It's great. It is great. So the two big things here for Carlos is that he says that the car is slowing down for the entire distance it travels. And he also is claiming that the slope of the line is always negative and never changes. Do you agree with either of those pieces? Take a look. Yeah? Do you agree with both of them? Let me ask about the green one. The green one is kind of like the statement. The green one says the slope of the line is always negative and never changes. Do you agree with that?
Yes.
The slope of the line is always negative. And it's constant. That means it never changes. So I would say that makes sense. Sure. The slope of the line is constant and never changes. Is negative and never changes. Excuse me. Does that mean that the car is slowing down during the entire story? Why not? Yeah.
Because it goes past 0 to the negative, which means that it starts speeding back up.
Right. So we have to really interpret this graph and understand what's going on. So right up here, the car is moving with a constant positive velocity, right? It's going fast. And then as time goes on, what's happening to its speed? It's slowing down, right? So this is like you're driving, you put the brake on, and now you're slowing down. And right at this moment, at 3 seconds, tell me about your speed.
Is it greasy?
What did you say? I'm sorry.
It's increasing by the opposite direction.
Your speed is at this moment, at 3 seconds, at that moment, what's happening? You stopped. Just for a moment, right? You stopped just for a moment. And then you're speeding up, right? Does that make sense? Because remember, we need to differentiate between speed and velocity. Speed is just a magnitude, and it is always, I don't know why I didn't write the S, always positive. Velocity can be positive or negative, right? The speed is basically, it's the absolute value. It's basically how far are you away from 0, okay? In which case am I going faster? You ready? If I have a velocity of -3 or a velocity of 2. -3, even though it's a smaller number, right? On the number line, it's a smaller number. I'm actually going faster because my speed is bigger. The absolute value of that number is bigger. Okay? So that's the piece that's really important to kind of internalize. So before we even look at this evidence business, do you guys agree with Carlos? 100%? Some way, somewhat, but not all the way, or not at all? Somewhat, right? The green part? Yeah, Carlos, you're right. But the conclusion that you're drawing from that, not quite right. All right, let's take a look at the evidence here. So the evidence says, fill in the blanks and circle the appropriate choices to complete the following statement of evidence to disprove, because we know that that's now the right choice, Carlos's claim. Okay? So we're just going to go around the table. We're just going to go around and around and around. Here it comes. So, and each time we get to your table, somebody else needs to talk. Okay. So if you need to think or whatever, or if you just don't know and you just want to process with the group, that is 100% okay too. Okay. We're all here to learn together. So it says the car starts with an initial velocity of, back table, what you got? 12 what? Oh, I guess it does have the meters per second there, doesn't it? Sorry. But yes, 12 meters per second. And is slowing down for the first 3 seconds. Are we okay so far? Everybody's happy. Okay. And what'd you guys say for the next little part? Slowing down or speeding up?
Speeding up.
It's speeding up for the last second. Okay. At 3 seconds, the car's motion changes from traveling in the, so it says in the positive direction or in the negative direction. So what do we say there? Did you say one? I didn't hear you. So at 3 seconds, the car's motion changes from traveling in the negative direction to traveling in the positive direction. Do you guys agree with that?
No. I was gonna do all one.
You were looking at the backwards one?
Yeah.
So what should the first one be?
It's my positive and negative.
Yeah, in the positive direction to traveling in the negative direction. Everybody cool so far? Awesome. Okay, the horizontal intercept represents the back table. The horizontal intercept represents the time? Yeah. When the velocity of the car is equal to, it's true. The car accelerates constantly with a magnitude of, -4 meters per second squared. Because the, help me out. Yeah. Okay. So the game is, friends, that on an AP exam, they would say, Carlos says this, and then they would say, respond. Or they would say, how do you either prove or disprove that? And you have to write this kind of narrative out to explain whether you agree or disagree. So this is not just a game of fill in the blank, even though it kind of feels that way. It's really important, you might want to put a big star by this, to internalize the way that they're articulating what's going on, okay? This is the kind of narrative you have to have in order to explain what you think about Carlos's claim. Okay? All right. And then using representation. So now we have the opportunity to draw some graphs, don't we? So this is going to be kind of nice, given that we just had a conversation about this on our warm-up problem. So use the graph in part A to draw an acceleration versus time graph for the motion represented above. You've got whiteboards in front of you, don't you? Go ahead and do part C on your whiteboard right now.
So, wait, so.
All right, let's take a look. Let me see your graphs. You'll notice just a little quick note, and I think most of you caught this, but just to be clear, that this says to draw an acceleration versus time graph, not sketch, right? So you actually need to make sure that your lines and whatever are in the right spot. So what is the value of the acceleration? -4, the whole darn way. So it's just going to be a horizontal line, like so. Okay? And then, that one was pretty easy. Would you agree? Good. Yay for us in our multiple languages here. All right. It says, use the graph in part A to draw a position versus time graph for the motion represented above. The position versus time graph will pass through the 2 dots plotted for you. Now, before you do any graphing, hold on. Put your markers down. Because, remember, they're holding your hand, but I want to make sure that you see where they're leading you. Where in the world do these dots come from? That's a good question.
It's, oh, no, wait.
Where do those points come
The
from?
farther it gets from the distance, okay, sorry, I
did the
totally messed
You're
up.
okay.
Okay, but it's the farther away, as the thing, why can't I word this right?
You're okay. Go ahead and just keep talking.
It's just, okay, the further away you go, the farther it gets then, so that's why it's going to that line, and then it stops, but the time's still going, so that's why it's like, I think I'm just describing the graph.
You are, yes. I want to know where this point comes from.
Yeah.
Where does that point come from? How do I know that this point should be on the graph? Any idea?
Because at 0 time you traveled 0 meters.
Yeah, at 0 time, not even as he traveled 0 meters, but they said specifically up here that they're starting from a position of x equals 0. Okay? And that's not arbitrary. That's actually like it says that, so we need to include that. Where does that other point come from?
That's where they, yeah.
How do you know? Let me ask a question. So you know that because the time equals 3 at that point? Sure. If they had not plotted this point for you, could you find the value? How do you, okay, so I like that you just held the graph up and said, you just look at that. I mean, you're not wrong. So I'm going to look at that. I'm looking. I don't see, what was it, an 18? Where does the 18 come from?
That's actually what I did.
Where does the 18 come from?
Area.
Triangle?
Yes.
Triangle? What do you mean triangle?
The area of the triangle is this place.
How? What? How are you? What?
That's what I did.
Because that's what I did and that's what I know. Why is the area of this triangle the displacement? Can you prove to me in any way that the area of this triangle, I mean, like, besides the fact that the area of the triangle is 18?
Well, if you multiply,
Keep talking.
by time you didn't.
Let's look at units to start. If I multiply meters per second times seconds, the meters, the seconds are going to cancel, so I've got meters. Yeah. And we're going to go through this more, but I want to make sure that this actually sits okay with you, okay? If I was moving at a constant velocity of 12 meters per second for 3 seconds, let's just think about that for a second. If I'm moving at a constant velocity of 12 meters per second for 3 seconds, after 1 second I've gone 12 meters, and after 2 seconds I've gone 24, and after 3 seconds I've gone 36 meters, right? Does that make sense?
Yes.
Okay, so that would be like the whole darn thing. Come on, silly thing. That would be this whole box. But I'm not going 12 meters per second for the whole story. I'm going less and less and less and less fast all the way until I get here. Okay? I am going to divide by 2 because I start off going 12 meters per second and I end up going 0 meters per second. So you can look at this a couple different ways. One approach is to say, well, sure, because I've seen that before. Question for you. This is a brain stretch question, whether you've done calculus or not. What is it a car? What is the car's average velocity over those first 3 seconds? How do you find the average velocity?
Negative 6.
What is the car's average velocity? Hold on, guys, I don't want you to be smart about, I want you to be smart, but I don't want you to be sassy, but I want you to think about it. If it starts off going 12 meters per second, and it ends up going 0 meters per second, what's its average velocity? Negative 6? Negative 6 is down here.
Or, 6.
How do you find the average between two numbers?
Add them, divide by however many numbers.
12 plus 0 divided by 2 is 6. Okay? Because the values of the velocity are positive. This is why I want to have this conversation, right? Because I don't want you to get so wrapped up in the negative slope that you get mixed up. You with me? Right? I want you to make these mistakes now while we're here together so that we can make mistakes together and learn, as opposed to making these mistakes later. So another way to look at it for my non-calculus friends, if you're not like, where is this triangle thing coming from? I know that I'm going not 12 for the entire time, but my average speed, if instead I was not slowing down, I was just going at one speed, it would be going 6 meters per second for those 3 seconds. Yeah? 6 meters per second for those 3 seconds is the same as the area of this triangle. Yeah? Regardless of how you do that area, take the whole big thing and divide by 2, take the area of the triangle, or take the area with the average speed, that blue one that I've drawn. Any of those ways, you're going to get a displacement of how much? 18, right? Now, we have not answered the question. All we've done is plotted those 2 points. So right now, on your boards, I want you to talk about it, have a conversation, figure it out. Go, go, go. Let's do that, shall we? All right. So I'm seeing here lots of things. We can all agree on these 2 points. Yeah? Now, before we look at all of your graphs, I want to go back to the warm-up problem that we did today. Okay? I want to go back to the warm-up problem to get our heads around this, because you guys, there is so much good physics and so much rich conversation here, and I want to make sure you see it and you understand it. Our acceleration was constant, right? This is the problem we did at the beginning of the period. Our velocity was increasing. Our velocity was increasing because our acceleration was constant, and the slope of velocity gives you acceleration. The slope of the position versus time graph gives you velocity. Are you with me there? So remember here, friends, guys, stay with me for just a second, that the slope here is getting bigger and bigger and bigger. Yeah, you with me? And that's because the acceleration is getting bigger, the velocity is getting bigger and bigger and bigger. Slopes are increasing because values are increasing. Okay. We're going to work backwards this time. So now we're looking at the acceleration versus time graph and the velocity versus time graph. So without drawing anything, question for you. Where in this whole story is the velocity the greatest? At the beginning, right? So the velocity is the greatest at t equals 0. That means that the slope should be the greatest where? Do you understand what I'm asking?
Yes.
The velocity is the greatest right here at t equals 0. So that means that the slope of the velocity versus time graph should be the greatest where? Near the beginning, right? So you should have a big slope here. Quick question for you. What should the slope of the displacement versus time graph look like at t equals 3? The slope should be 0 here. Are you with me? Because the value here is 0. So that means that the slope should be 0 here. And then talk to me about the slope after t equals 3. What happens to the slope after t equals 3? What happens to the values of the velocity? They get negative. So that means that you should have a big positive slope here. You have a negative slope here. You with me? What's that going to look like, friends? We're kind of trying to put things together, trying to get our head around this.
Negative x.
negative x minus
That's kinda ugly.
squared plus 18.
Mine was ugly too.
That's the graph.
Yeah.
Yes, it is.
It's quadratic.
It is a quadratic. It's a parabola.
Oh. Plus 18. I don't think so, Jake. Yeah, you're right.
Yeah.
You're right. He's definitely right. I don't think so.
How we doing?
The domain is 0, 4.
All right. Shh. I just want to see how we're doing, how we're processing this. For some people, that's an aha moment that just takes 5 seconds. For some people, this takes a while to like kind of sink in. Okay? And we are going to sink it in a little bit tomorrow as well. But this is what we're talking about. The slope at time equals 0 is really, really big. And then it gets less steep. This is not a great parabola, but you get the idea. And then it becomes negative, and it becomes more negative as you go. The slopes of this line vary, and with that, the velocities vary. Okay? All right. So here's the deal, my friends. I feel like this is a pretty good stopping spot, but a couple of quick things here.